Hello everyone, I am Jyoti Bhom, and in this video we are going to see the information about remote sensing. So first of all we will see what is remote sensing. So remote sensing is an art and science of obtaining information about an object or feature without physically coming in contact with that object or feature. So this is done by sensing and recording reflected or emitted energy and processing, analyzing and applying that information. So generally the humans apply remote sensing in their day-to-day business through vision, hearing and sense of smell. Now, who uses the remote sensing and what is the purpose behind using the remote sensing, that we will see. So first we will see about the geographer. So geographer is the one who looks for changes on the earth's surface that need to be mapped. Next is the forester, who needs information about what type of trees are growing and if they have been affected by disease or fire. Then the environmentalist. So environmentalist wants to detect, identify and follow the movement of pollutants such as oil slicks on the ocean. Then the geologist, so who is interested in finding valuable minerals. The farmer wants to keep an eye on how his crops are growing and if they have been affected by drought, floods, disease or pests. The ship captain, this captain needs to find out the best route through the northern ice packs. The firefighter, who sends out his crews based on the information about the size and movement of a forest fire. And the urban planner, who wants to map and monitor land cover, land use, morphology, etc. So morphology is nothing but the study of form of human settlements and the process of their formation and transformations. So these are the various purposes based on which the remote sensing is used. Now here we will discuss about the remote sensing process. So here in the image you can see the various elements of remote sensing and like A, B, C, D, E, F and G. So we will see those elements one by one which forms the process of remote sensing. So the first of all is the energy source or illumination, that is A. So the first requirement for remote sensing is to have an energy source which illuminates or provides electromagnetic energy to the target of interest. Then next is radiation and the atmosphere, that is B. So as the energy travels from its source to the target, it will come in contact with and interact with the atmosphere it passes through. This interaction may take place a second time as the energy travels from the target to the sensor. Then the next is interaction with the target, that means C, interaction with the target. So once the energy makes its way to the target through the atmosphere, it interacts with the target depending on the properties of both the target and the radiation. The next is D, that is recording of energy by the sensor. So after the energy has been scattered by or emitted from the target, we require a sensor to collect and record the electromagnetic radiation. Then the transmission, reception and processing. So the energy recorded by the sensor has to be transmitted and often in electronic form to a receiving and processing station where a data are processed into an image that may be available in hard copy or in a digital form. And the next is the interpretation and analysis, that is F. So this processed image is interpreted visually or digitally or electronically to extract information about the target which was illuminated. And the next is application, that is G. So the final element of the remote sensing process is achieved when we apply the information we have been able to extract from the imaginary about the target in order to better understand it, reveal some new information or assist in solving a particular problem. So this is the overall process of a remote sensing. Now we will see the platforms and sensors. So the sensors are nothing but the devices that records electromagnetic energy, whereas platforms are nothing but the carrier beds which are used to carry the sensors. Now we will see those platforms and different types of sensors in detail. So the platforms are used to house the sensors which obtain data for remote sensing purposes. The distance between the target being imaged and the platform plays a large role in determining the detail of information obtained and the total area imaged by the sensor. So the platforms are of different types like ground based, airborne platforms, spaceborne platforms. So the ground based remote sensors are very close to the ground. They are basically used to develop and calibrate sensors for different features on the Earth's surface. And the airborne remote sensors are available in different altitude like low altitude and high altitude, whereas the spaceborne platforms, the example of spaceborne platforms are space shuttles, polar orbiting satellites, geostationary satellites, etc. So from each of these platforms, the remote sensing can be done either in passive or active mode. So these passive or active are nothing but the types of sensors. So depending on the source of electromagnetic energy, the remote sensing can be classified as passive or active remote sensing. So in the case of passive remote sensing, source of energy is that naturally available, such as the sun. And in the case of active remote sensing, energy is generated and sent from the remote sensing platform towards the targets. The energy reflected back from the targets are recorded using sensors on board the remote sensing platform. The most of the microwave remote sensing is done through the active remote sensing. So here the examples of passive sensors are normal photography, and the most optical satellite sensors are the passive sensors. And the example of active sensors are radar sensors, laser altimeters, etc. Now we will discuss about some advantages and few disadvantages of remote sensing. So first of all, we will see the advantages. So here is the list of some advantages and disadvantages of remote sensing. So the advantages of remote sensing are: it provides the data of large areas, it provides data of very remote and inaccessible regions, it is able to obtain imagery of any area over a continuous period of a time through which any and natural changes in the landscape can be analyzed. Relatively, it is expensive when compared to the employing a team of surveyors, and it is easy and rapid collection of data and the rapid production of maps for interpretation. So these are the various advantages of remote sensing. Now there are few disadvantages of remote sensing, which are: the interpretation of imagery requires certain skill level. It needs a cross verification with ground or field survey data. The data from multiple sources may create confusion, and objects can be misclassified or confused, and the directions may occur in an image due to the distortions may occur in an image due to the relative motion of sensor and source. Now we will discuss about the Geographic Information System, that is GIS. So the Geographic Information System designed to capture, store, manipulate, analyze, manage and present all types of geographically presented data. The geographical information systems are computerized systems designed for the storage, retrieval and analysis of geographically presented data. So GIS uses advanced analytical tools to explore at a scientific level the spatial relationships, patterns and processes of cultural, biological, demographic, economic, geographic and physical phenomena. The GIS stores related geographic features in separate collections of files called map layers. And map layers can be reused easily and assembled into any number of map compositions and overlaid for analysis. Now we will see the various applications of remote sensing and geographical information system in civil engineering. So the first application of remote sensing and GIS is in agriculture and soil. So it is used in agriculture and soil for precision agriculture, for crop production estimation, soil and land degradation mapping, etc. In forest biodiversity and environment, it is used for forest cover and type mapping, biodiversity characterization, environmental impact studies, monitoring of environmental sensitive area, monitoring of wetland areas, forest fire and risk mapping. Then in case of engineering and geology, it is used for mineral potential mapping, groundwater potential zoning, infrastructural planning, etc. In regional or land development, it is used for town and country planning, land alienation, solid waste disposal, etc. And in marine and oceanography, it is used for potential fishing zone, coastal zone mapping, marine resources, physical oceanography, etc. In disaster management, it is used to monitoring and mapping of disaster areas like forest fire, flood and landslide. Then landslide hazard zonation, then for flood damage assessment, for forest fire assessment, etc. Then in meteorology, it is used to identify extended range monsoon forecasting, ocean state forecasting, etc. In water, it is used for potential drinking water zones, monitoring of catchment, etc. In environmental health, the application of GIS is for dengue risk mapping zoning, children malnutrition study, air pollution study, tick-borne diseases, etc. In land use monitoring, the application of remote sensing and GIS is to land use or land cover mapping, then wasteland mapping, topography and geographic positioning, urban development, geology, etc. And in case of national security, the application is for intelligence, territorial security management, mapping and rescue planning, then strategic and tactical ground mobility, etc. So these are the various applications of remote sensing and GIS in civil engineering. So here are some images of remote sensing which with the help of we can take a help of those images for various uses like forest monitoring, land use change, then to identify the flood mapping, etc. So in this video we have covered the information about the remote sensing, the various elements of remote sensing which forms the process of remote sensing, the few advantages, disadvantages of remote sensing, the application of remote sensing in civil engineering. We have also discussed about the geographical information system and as well as the application of the same in civil engineering. Thank you.